For more than a century, the dominant scientific framework has defined consciousness as nothing more than an emergent byproduct of neural activity. Within this view, subjective experience is treated as a secondary phenomenon, fully reducible to electrochemical interactions inside the brain. Thoughts, emotions, and identity are assumed to arise automatically once neural complexity reaches a sufficient threshold. This assumption has shaped neuroscience, psychology, and medicine at a foundational level. We are commonly taught to think of the brain as a generator, much like a turbine that produces electricity through mechanical motion. In this analogy, damage to the brain should permanently destroy the mind in the same way that a broken turbine halts power production. Mental states are therefore believed to depend entirely on biological output. While intuitive, this comparison embeds an assumption that is rarely questioned at a deeper philosophical level. However, a growing body of clinical and neurological anomalies has begun to challenge this strictly materialist interpretation. Certain medical cases do not align cleanly with the idea that consciousness is produced solely by neural firing. These anomalies are not fringe observations, but documented phenomena that persist across cultures and clinical environments. Their existence suggests that the current explanatory model may be incomplete. One of the most persistent obstacles is what philosophers and scientists refer to as the hard problem of consciousness. This problem highlights the gap between objective brain processes and subjective experience itself. Neural activity can describe correlations, but it does not explain why experience exists at all. No amount of biological reduction has yet resolved this fundamental question. As unresolved questions accumulate, signs of a gradual paradigm shift are becoming more difficult to ignore. Scientific progress often advances not by refining existing answers, but by questioning the assumptions behind them. When anomalies persist long enough, they signal the need for a broader conceptual framework. Consciousness research appears to be approaching such a transition point. This shift invites a reconsideration of a radical but logically consistent possibility, that the brain may function as a receiver rather than a producer of consciousness. In this model, awareness exists independently of neural tissue, while the brain modulates, localizes, and expresses it. Damage to the brain would then distort experience without necessarily eliminating its source. The distinction between generation and reception is not a minor technical detail. It fundamentally alters how we interpret identity, perception, and continuity of awareness. If consciousness is received, then the brain is an interface rather than an origin point. This reframes many unanswered questions that conventional neuroscience struggles to resolve. Ultimately, this perspective forces a deeper reconsideration of life and reality itself. Consciousness may not be a late-stage biological accident, but a foundational aspect of the universe that biology interacts with. The implications extend far beyond neuroscience, touching philosophy, physics, and human self-understanding. What we are may be far more expansive than what our biology alone can explain. A useful way to approach this alternative model is through a functional analogy that separates signal from mechanism. A television set does not generate the broadcast it displays, but receives and decodes an external transmission. The screen, speakers, and circuits shape the output, yet the signal itself exists independently of the device. This analogy allows us to reframe how brain activity relates to conscious experience. When a television is damaged, the image may distort, fragment, or disappear entirely. However, no one concludes that the broadcast signal itself has ceased to exist. The distortion reflects a limitation in the receiver, not a destruction of the source. Applying this logic to the brain suggests that altered cognition may indicate impaired filtering rather than the elimination of consciousness itself. Modern neuroimaging technologies have significantly advanced our understanding of brain function, but their findings remain correlational in nature. Brain scans reveal patterns that accompany thoughts and perceptions, yet they do not demonstrate that these patterns generate awareness from nothing. Correlation explains timing and location, not origin. This distinction is often overlooked in popular interpretations of neuroscience. More challenging for the generative model are clinical cases involving individuals with drastically reduced brain tissue who nonetheless display coherent cognition. These cases are rare but well documented, and they do not align with expectations derived from neural volume alone. Functional consciousness in such scenarios suggests that the brain may not be the sole repository of awareness. The data points toward an alternative explanatory framework. If consciousness persists under conditions where biological capacity appears insufficient, then it may be more accurate to view it as a fundamental property rather than a secondary effect. Much like gravity or electromagnetism, consciousness could exist as a pervasive feature of the universe. Biological systems would then interact with it rather than invent it. This view remains speculative, but it is increasingly difficult to dismiss outright. Within this framework, the nervous system operates as a sophisticated filter rather than a raw generator. Its role would be to reduce an overwhelming field of information into a manageable stream of experience. This filtering allows for stability, identity, and functional interaction with the environment. Without such reduction, conscious input might become chaotic and unstructured. The selective nature of perception supports this idea. Human awareness is remarkably narrow compared to the total information available in the physical world. We perceive only a thin slice of electromagnetic, auditory, and sensory data. Such selectivity suggests intentional limitation rather than maximal output. Taken together, these observations imply that the brain's primary function may be reductive and organizational rather than generative. Consciousness is shaped, localized, and constrained by biology, but not necessarily created by it. This interpretation preserves scientific rigor while opening space for a more comprehensive model of awareness. It also prepares the ground for deeper explanations beyond classical neuroscience. Classical neuroscience encounters a significant limitation when attempting to explain the unified nature of conscious experience. Billions of neurons fire independently, yet subjective awareness presents itself as a single, continuous field. There is no clear mechanism within classical models that explains how distributed signals merge into a seamless sense of self. This gap remains one of the most persistent challenges in brain science. Traditional explanations rely on synchronized neural firing, but synchronization alone does not account for subjective unity. Coordination describes timing, not experience. Even perfectly aligned neural activity fails to explain why consciousness feels like something from the inside. This limitation suggests that another layer of processing may be involved beneath observable neural events. Quantum biology has emerged as a field that explores biological processes operating beyond classical physics. Certain cellular functions appear to rely on quantum coherence to achieve efficiency and speed. These findings demonstrate that living systems can sustain quantum effects in warm, wet environments once thought impossible. This opens the door to re-examining cognition at a deeper physical level. One of the most discussed proposals within this domain is the orchestrated objective reduction theory. This framework suggests that quantum-level vibrations occur within microtubules, structural components found inside neurons. Rather than being passive scaffolding, microtubules may play an active role in information processing. This theory places the roots of consciousness far below synaptic signaling. If quantum coherence operates within neural microstructures, then the brain's function extends beyond chemical transmission. Information processing may occur simultaneously across multiple states rather than through linear signaling alone. Such parallelism could help explain the speed and unity of conscious experience. The brain would then function as a quantum classical hybrid system. Biological coherence also raises the possibility of interaction with external quantum fields. Coherent systems are, by definition, sensitive to subtle informational inputs. This sensitivity could allow biological structures to resonate with information beyond their immediate physical boundaries. Such resonance would not violate physics, but operate within its less intuitive principles. Physics itself permits non-local effects, where information is correlated across distance without direct contact. These effects have been repeatedly verified at the quantum level. While controversial, extending non-local principles to biological systems is no longer dismissed outright. The implications for cognition and awareness are substantial. Taken together, these insights suggest that the brain may be accessing information rather than manufacturing it entirely internally. Neural activity would then represent the interface expression of a deeper informational process. Consciousness, in this view, is not confined to the skull but mediated through it. This interpretation bridges neuroscience with physics without abandoning empirical discipline. From an evolutionary perspective, the primary function of the brain was never to reveal reality in its entirety. Survival favored organisms that could act quickly and efficiently, not those overwhelmed by excessive information. Natural selection therefore shaped perception to be useful rather than accurate. Conscious awareness became optimized for action, not truth. This view reframes the brain as a limiting mechanism rather than an expansive one. Instead of maximizing awareness, evolution favored systems that narrowed perception to what was immediately relevant. Anything beyond survival utility was filtered out. Consciousness, under this model, is intentionally constrained. This idea was famously articulated by Aldous Huxley, who described the nervous system as a reducing valve. According to this concept, the brain limits a much broader field of awareness into a narrow channel suitable for daily functioning. Without such reduction, the sheer volume of experience would be incapacitating. The mind would be flooded rather than focused. Modern research into altered states of consciousness provides empirical support for this hypothesis. When normal filtering mechanisms are relaxed, brain activity often becomes more entropic rather than more ordered. This increased entropy corresponds with expanded subjective experience, not diminished awareness. The data suggests less constraint can produce richer perception. Interestingly, these states are frequently described as more real or vivid than ordinary waking consciousness. This contradicts the assumption that clarity requires tighter neural control. Instead, excessive control appears to suppress depth and complexity. Awareness expands when the brain loosens its grip. Contemporary neuroscience increasingly views ordinary perception as a controlled hallucination. The brain continuously predicts reality and corrects itself using sensory input. What we experience is not raw data, but a stabilized internal model designed for efficiency. Accuracy is secondary to functionality. Within this framework, the body serves as an anchoring mechanism for non-local awareness. Biological constraints lock perception into a specific viewpoint in time and space. This anchoring creates the experience of individuality and separation. Without it, consciousness may lack definable boundaries. Sensory input, rather than expanding awareness, primarily serves to mask a deeper background field. The constant stream of signals occupies attention and stabilizes perception. In doing so, it prevents access to a broader spectrum of consciousness. What we call normal awareness may therefore be a narrowed slice of a much larger reality. Some of the most compelling challenges to the brain as generator model emerge from near-death experiences occurring during cardiac arrest. In these cases, blood flow to the brain ceases and measurable cortical activity rapidly collapses. Under conventional assumptions, conscious experience should fade or disappear entirely. Yet, reports from survivors consistently describe the opposite. Patients often recount episodes of heightened clarity, expanded awareness, and detailed perception during periods when the brain shows little to no organized activity. These experiences are frequently described as more vivid than ordinary waking consciousness. Importantly, they occur when the neurological conditions required for hallucination are absent. This timing presents a serious explanatory problem for materialist models. Electroencephalographic data collected during cardiac arrest confirms prolonged periods of flat or near-flat cortical signals. Despite this, subjects later report structured memories, coherent narratives, and complex emotional processing. These reports are not random or fragmented, but internally consistent. The data suggests consciousness can operate independently of normal neural support. An equally puzzling phenomenon is terminal lucidity, in which individuals with severe neurodegenerative damage briefly regain mental clarity shortly before death. Patients who were previously unable to recognize loved ones suddenly engage in meaningful conversation. This clarity appears without any corresponding biological repair. Such cases contradict the assumption that tissue health directly determines cognitive capacity. If consciousness were strictly dependent on neural integrity, such reversals would be impossible. Degenerated structures do not spontaneously regenerate moments before death. The return of clarity, therefore, suggests that the limiting mechanisms of the brain may be temporarily disengaged. What emerges appears to be access rather than reconstruction. Emotional memory also appears remarkably resilient under these conditions. Individuals often recall emotionally significant events with precision, even when short-term memory had previously failed. This persistence implies that emotional encoding may not be stored solely within localized neural circuits. Instead, it may involve a broader informational substrate. Intuition further complicates the conventional model. Intuitive insights often arise without conscious reasoning or sensory input. Yet they can be accurate and contextually appropriate. Such information appears to bypass standard perceptual filters. This suggests access to knowledge not derived from immediate sensory processing. Taken together, these phenomena point toward internal processing that may tap into a shared and non-local informational field. Consciousness, in these moments, appears less constrained by biological filters. The brain no longer dictates awareness, but merely mediates its expression. These observations demand a framework that extends beyond tissue-based explanations. If consciousness is a fundamental aspect of reality rather than a private neural product, then individual minds cannot be fully isolated entities. What appears as separation may be a functional illusion created by biological boundaries. Each brain would localize awareness, but not originate it independently. This perspective reframes individuality as modulation rather than ownership of consciousness. The sense of being a separate self arises largely from the brain's structural constraints. Neural architecture defines perspective, memory, and identity, giving rise to the experience of personal boundaries. These boundaries feel absolute, yet they may be perceptual rather than ontological. Separation may be a feature of interface design, not a property of consciousness itself. Field theories in physics offer a useful analogy for understanding this possibility. Fields exist continuously across space, while localized disturbances appear as individual events. In such models, separation is apparent rather than fundamental. Consciousness may operate in a similar way, with individual minds representing localized expressions within a continuous field. Empirical research into global coherence provides intriguing, though controversial, data supporting collective interaction. Studies suggest that large-scale emotional events correlate with measurable changes in random systems. While interpretations remain debated, the data challenges the assumption that observers are completely independent. Collective states appear to exert subtle but detectable influence. At the quantum level, entanglement demonstrates that systems can remain correlated regardless of distance. These correlations do not transmit classical signals, yet they preserve informational relationships. If biological systems can maintain coherence, interaction with such non-local correlations becomes theoretically plausible. The environment and observer may therefore be continuously linked. Human social behavior also reflects synchronization beyond explicit communication. Emotional contagion, group coherence, and shared mood shifts occur rapidly and often unconsciously. These phenomena suggest alignment at a level deeper than verbal or sensory exchange. Resonance may precede explanation. Neural entrainment further supports this idea. Brains naturally synchronize rhythms during shared attention, conversation, and cooperation. This synchronization improves understanding and coordination. It may represent a biological expression of deeper informational alignment rather than mere coincidence. Taken together, these observations suggest that human beings exist within a shared spectrum of awareness. Individual experience remains localized, but not fundamentally separate. Consciousness may be continuous, while identity is discrete. What we perceive as isolation may simply be the tuning of a shared field into individual channels. Accepting consciousness as fundamental rather than derivative forces a reconsideration of how we approach mental health, identity, and the nature of death. If awareness is not fully extinguished by biological failure, then psychological well-being cannot be reduced to neural chemistry alone. Treatment models would need to account for the quality of the interface, not just its material condition. This perspective expands responsibility beyond symptom suppression. Science, as a discipline, evolves by expanding its explanatory boundaries. Historically, phenomena once considered subjective or unmeasurable eventually became legitimate areas of study. Consciousness may represent the next frontier in this progression. Rather than rejecting subjective experience, science is gradually learning how to integrate it without abandoning rigor. Within this expanded framework, the brain remains critically important, but its role is reframed. It acts as an interface that shapes, filters, and localizes awareness into a functional human experience. Damage to the interface alters expression, not necessarily existence. This distinction preserves the value of neuroscience while correcting its overreach. Future research may therefore shift focus from solely repairing tissue to improving interface coherence. Factors such as neural noise, signal clarity, and systemic integration may become central areas of investigation. The quality of consciousness could depend more on alignment than on raw biological output. This reframing opens new methodological possibilities. If identity is not fully produced by the brain, then it may not be confined to the biological lifespan of the body. Death would represent a transition in interface rather than annihilation of awareness. While this conclusion remains speculative, it is logically consistent with the evidence presented. Importantly, it arises from observation rather than belief. Understanding consciousness through a frequency-based model also provides a rational foundation for interconnectedness. Empathy, intuition, and shared meaning become natural consequences rather than anomalies. Human connection may reflect resonance within a shared field rather than social conditioning alone. Separation becomes functional, not absolute. This perspective does not diminish individuality, but contextualizes it. Personal identity emerges as a localized pattern within a broader continuum of awareness. Meaning is preserved, but isolation is softened. The self becomes a dynamic expression rather than a closed system. Ultimately, this model suggests that consciousness is not produced by reality, but is the medium through which reality appears. Physical structures shape experience, but do not create its existence. Matter becomes the canvas, not the source. Consciousness remains the primary field upon which all observable phenomena are drawn.